Okay, in this section, we're gonna get into some properties of shapes and perimeter, area, and get into finding angles for shapes. So we're gonna start with kind of some definitions, and we'll get into more of the specifics of the definitions and how to find areas of different types of angle or shapes. But for now, like in general, the very basic way to describe shape is a polygon. And so a circle technically is an apolygon, but pretty much anything else that you can think of, a trapezoid, a rectangle, a square, as long as every single side is a straight line, that is a polygon. You can have however many sides you want. You could have 30 sides, that's still a polygon. Now this very specific type of polygon is a rectangle, and a rectangle has to have two equal sides opposite each other, and it will have 4 right angles in the rectangle. And so if we're going to be very formal with how we're naming things, you would name your sides like this, and you would name your vertices like this. Vertices could also, like if we're dealing with a capital letter, that could just also be the way we are describing that angle. We generally won't get that formal, but you might see that type of naming elsewhere. Now, different definitions of kind of basic forms of polygons are the parallelogram. So parallelogram has opposite sides are equal and parallel, but it doesn't have that requirement of rectangles of having 4 right angles, 4 angles, or 4 angles of 90 degrees, I think is what I was trying to say. Now we talked about a rectangle already. It's a square, or sorry, it has 2 equal sides, except for where we have that requirement that we have 4 right angles. And then a square is a rectangle that has all equal sides. So all the sides are going to be equal, and you're going to have 4 90-degree angles. I imagine this is a bit of review for some people, but it's worth kind of going through the formal definitions again. Now, for area of a rectangle, we just take the length times the width, or the height times the base, or L times W. And if you wanted to find the width or the length, you could just take the area and divide it by your length. So I think actually those notes are not correct. Just go ahead and ignore those. But if you wanted to find the width or the length, you could just take the area and divide it by the other side. The perimeter of a rectangle is you take 2 times your length plus 2 times your width. And so that's the formula. But in general, if you're trying to find the perimeter of any polygon, you just add up the lengths of every single side on the outside of your shape. So with this rectangle, it's W plus L plus L, which simplifies to 2L plus 2W. And with a square, if we're trying to find the area, since both of the sides are equal, the length times the width in this case would actually just be, they'd be the same variable. So we could just take whatever single side we're given and we could square it. And then for a perimeter, very similar argument is now we're just adding up all of the sides. Well, they're all the same length, so it's just going to be 4 times S. But honestly, these formulas that you can see can be kind of derived, at least certainly the perimeter, by just kind of falling back on those definitions of, okay, I'm trying to find the distance around the shape, so I don't really have to memorize the formula. I just have to make sure that when I'm finding the perimeter, I meet that requirement. So we're going to try and find the area and perimeter of this rectangle. Area of a rectangle is base times height, 4 times 8, and then I have to make sure that I am squaring my units. By the way, if that single dash, I don't know if I mentioned it before, that's feet, 2 dashes is inches. So if you haven't seen that before, that's what that unit is. And now for perimeter, if we're going to use the formula strictly, we would do 2 times 4 plus 2 times 8, or you could just add up all of the sides and you would also get 24 feet. Now, area is always units squared. Perimeter is always just units because we're talking about a distance. Here we have a square. Just do 3 times 3. You could write the 3 on the other side if it helps you feel more comfortable, or you can just use the formula of 3 squared. So that's going to be 9 feet squared. And then your perimeter, it could be 3 plus 3 plus 3 plus 3, or simpler form, just 4 times 3. Gets me 12 feet. Now, we have to be a little bit careful if we're dealing with units. So in the first two examples here, I had all feet or I had all inches. Now I have feet and yards. So in order to find my perimeter and area, I kind of have to take that additional step of converting my units. So we know that there are 3 feet in a yard. So my 10 yards is going to be 30 feet. And so then I do 10 times 30 to get my area of 300 feet squared. Now you might be thinking, oh, well, what if I converted my feet into yards? That's perfectly fine. And in fact, I didn't really specify in the question. Usually I should specify and say, okay, give me your area in feet squared. But since I didn't, you could fully argue and just run through your process. Your area would look like it's much smaller, but they're equivalent. You just have to convert if need be. And then same thing with perimeter, just 2 times 10. Now that I have my conversion, that 10 yards is 30 feet. I'm doing 2 times 30. Add those two together, I get 80 feet. Oh, and if I wanted to potentially find a side of a square, so let's say I knew my area of my square was 100 feet squared. If I wanted to find the length of one of my sides, I would just take the square root of that 100. And this formula is actually correct, so that's good. Okay, one last formula in this section is when we're dealing with angles of not polynomials, polygons. Ooh, I'm on fire in this lecture. Polygons. So if I have that polygon, which means I have a shape where all of my sides are straight lines, I can figure out the total measure of all of the angles in my polygon by using this formula. So to kind of put it into context with a triangle, we know that all 3 sides add up to 180, which makes sense with this formula. N is 3, 3 minus 2 is 1, 1 times 180 is 180. Similarly, we know in a square, all of the angles sum up to be 360. Maybe we don't know that, but now we do. So in this formula, to kind of check that, n is equal to 4. I do 4 minus 2 is 2 times 180 gets me 360. So it makes sense, but once we get kind of beyond those simple cases and have, let's say, a polygon with 30 sides, then it becomes a little bit less obvious, and that's why the formula becomes helpful. So here I have a 1, 2, 3, 4, 5, 6, 7, 8, an octagon. And so I want to find the angles, measurements of angle A and angle B. I'm going to find the sum of all of the measurements of my angles in my polynomial for starters. So I plug in 8, I subtract 2, and then I'm going to multiply it by 180 using my formula. And so then I know the total sum of all of the angles in my polygon is 1080. Now I want to find a specific angle. Well, I have 8 angles in my shape, and in this shape, since all of my sides are equal, all of my angles will also be equal. So now I just take that total amount, I divide it by 8, and now I know my A is 135 degrees. And then to find B, well, that's a straight line. For a straight line, we know that totals to be 180 degrees. So I just take 180 minus 35, and I see that the measurement of angle B is 45 degrees.